Hey, this video is on formal charge, and it is, I think it's page 7 of your notes packet. So pretty brief here. Again, something called formal charge. So sometimes there are two valid Lewis structures you can draw. So for example, methyl alcohol, which has this formula CH40, which has 4, 8, 14 electrons you can use. Well, you could have this structure, which I just got rid of. Give me a second. Sorry. All right, they're drawn back on there. Different color. Sorry. Again, this has got two valid Lewis structures. So they both have the correct number of total valence electrons. Everything's got 8 valence electrons around it. It's supposed to have 8 around it. So both of these are valid. They both meet the criteria for a correct Lewis structure. So we are going to assign formal charges to the central elements typically. The best Lewis structure is when the formal charge are as close as possible to 0. So elements want a formal charge of 0. And if there's a negative formal charge, you want it to be around the more electronegative element. So they really want to be 0. If you get everything to 0, that's great. And if there's a negative formal charge, it needs to be on the more electronegative element. So there's kind of a complicated formula for formal charge, but here's the easy way about it. Formal charge equals the valence electrons the element has minus dots plus bonds. So, for example, if we try to get the formal charge of carbon, right here, carbon's got 4 valence electrons. So for carbon, I would go, its formal charge would be its valence electrons, 4, minus the dots plus the bonds around it. Well, there's no dots, no unshared electrons. There are 4 bonds. So 4 minus 4, 0. 0 is a good formal charge. Elements really want a formal charge of 0. Oxygen has 6 valence electrons, minus the dots plus the bonds. Well, it has 1, 2, 3, 4 dots plus 2 bonds. 6 minus 6, 0. So both carbon and oxygen have a 0 formal charge there. That is good. If we look at this one, if we get carbon's formal charge here, so carbon would be its valence electrons 4, minus the dots plus the bonds. 1, 2, 3, 4, 5. Dots count as individual ones, so 1, 2, 3 bonds, 2 dots. 4 minus 5, carbon there is a negative 1 formal charge. 0 is better always. Oxygen would be 6 valence electrons minus 1, 2 dots plus 1, 2, 3 bonds. 6 minus 5 equals a positive 1. So those aren't horrible formal charges, but over here both carbon and oxygen are 0. Neither one of them are here. So this is the better structure. This has the better structure because the formal charges are closer to 0. I'll give you one more example of that. So down here we got, can't figure out why I can't go any further. As far as I can go. You got these two. If we draw in a structure for them, so nitrogen oxide, which is N2O, okay, N2O. So we're looking at 10 plus 6. We have 16 electrons we can use. Okay, 16 we can use. So one structure here would be if we had double bond, 2, 4, 6, 8, 10, 12, 14, 16. So that'd be one possible structure. Another possible structure would be, same thing, I think. We still could use 16 electrons, but now the nitrogen's in the middle. Double bond. Go there. So let's see which one is the better one. So let's assign formal charges to them. So here, our nitrogens would have the same formal charge here. So nitrogen would equal its 5 valence electrons minus 1, 2, 3, 4, 5, 6. 4 dots, 2 bonds. So nitrogen is a negative 1. And oxygen would be 6 minus 1, 2, 3, 4, positive 2. Remember, the more electronegative element, closer to fluorine in the periodic table, should have the negative charge. Well, oxygen is the more electronegative element. It should have the negative charge then, on normal negative formal charge. If we go over to this one, again, both nitrogens there would be -1, just so you know. This nitrogen, the first nitrogen, would be 5 minus 1, 2, 3, 4 dots and 2 bonds, so 6. That nitrogen's -1. The second nitrogen would be 5 minus 4, positive 1. And the oxygen would be 6 valence electrons minus 1, 2, 3, 4, 5, 6. 4 dots, 2 bonds. Oxygen would be 0. And here it was -1, -1, positive 2. These are going to be better. Again, you kind of have to judge a little bit, but you have a positive 2 in there. These are all closer to 0. Plus, if an element's going to have a negative formal charge, it should always be the element closer to fluorine on the periodic table, the more electronegative element. So there's formal charge briefly.